Zap! What was that? Have you ever reached for a doorknob and felt a sudden zap? That's static electricity, and it happens all the time. It might feel like magic, but it's actually science. It's all about tiny particles called electrons jumping around. These electrons are so small you can't even see them. They live inside atoms, which are the building blocks of everything around us. Think of atoms like tiny houses and electrons as tiny people living inside. Sometimes, these tiny electron people like to move from one house to another. When they do, it creates something called static electricity. Now, let's dive into the exciting world of electric charges and learn more about those shocking surprises. Everything around us, even you and me, is made up of atoms, and inside those atoms are even tinier particles called protons and electrons. Protons live in the center of the atom, and electrons zoom around the outside. Protons have a positive charge like the plus sign on a battery. Electrons have a negative charge like the minus sign on a battery. Usually atoms have an equal number of protons and electrons, so their charges balance out. But sometimes electrons get restless and decide to move from one atom to another. When an atom gains extra electrons, it becomes negatively charged. When it loses electrons, it becomes positively charged. These charged atoms are like tiny magnets. Opposite charges attract, and like charges repel. Just like magnets, they can push or pull on each other. Static electricity happens when we rub things together. Imagine rubbing a balloon on your hair. Electrons from your hair jump onto the balloon, giving the balloon a negative charge. Your hair, now missing some electrons, becomes positively charged. Remember, opposite charges attract. That's why your hair might stand on end. It's attracted to the balloon. The same thing happens when you shuffle your feet across a carpet on a dry day. Electrons from the carpet jump onto you, giving you a static charge. When you touch a metal doorknob, those extra electrons jump from you to the knob and zap! You feel a static shock. Section 4. Why some zaps pack a bigger punch? The strength of a static shock depends on a few things. First, it depends on how many electrons have built up. The more you rub, the more electrons move and the bigger the potential zap. Second, it depends on the material. Some materials, like wool and rubber, are really good at grabbing and holding on to electrons. Others, like metal, let electrons flow easily. Finally, it depends on the air. Dry air acts like an insulator, making it harder for electrons to move. Humid air is a better conductor, so electrons can dissipate more easily. That's why you get more static shocks in the winter when the air is dry. Section 5. Static electricity is everywhere. Static electricity isn't just about shocks, it's all around us. Lightning is a dramatic example of static electricity in action. The friction of ice crystals in thunderclouds creates a massive buildup of static charge, resulting in a giant spark of electricity. We even use static electricity in everyday life. Photocopiers and laser printers use static electricity to attract ink to paper. And some air filters use static charges to trap dust and pollen. So the next time you feel a zap, don't think of it as a nuisance. Think of it as a tiny reminder of the amazing world of electricity all around us.